The project that I have worked on is fast AES-128 Crypto-Core processor, and I have done the complete place and route using RM flow methodologies of IC Compiler II. For the synthesis stage, I have used the Verilog files from the OpenCore website, and I have uh, made changes in the main.tcl file to compile all the Verilog files which are pointed to a file, and this RTL file contains all the Verilog files. In the UPF, I have done the following changes. I have used one switchable domain from one of the instance of the top module. And in SDC file, I have set the multi-cycle path uh, from all inputs and to all the outputs for both setup and hold. This helped me reduce the setup and hold violations which after the pre-sop stage. The synthesis results are as below. I could generate the retention flop, but I removed them for the later stages as I could not fix the errors related to UPF even after using the power state tables. The leaf count that was obtained is around 48K, and the synthesis lag is minus 7.48, and the design power is 9 millivolts. For the init design, I had to do a lot of trial and error for the floor plan, and I chose 680 by 680, and I have kept the switchable domain almost at the center of the core. These changes I have done in order to reduce congestion. I have placed the pins on layer 4 and on the sides, like on the bottom side. Also, I have used the congestion switch for the create placement, which helped me again to reduce congestion. In the create power grid.tickle, I have done these changes to the edge width, and I have increased the horizontal pitch, and the vertical pitch is 10. I created the horizontal blockages on layer 4. These placement blockages were required because the VDD and VSS were getting routed all the way down to the pins, and there was hardly any space for routing. So I removed these routing blockages at the end of the script so that I can route other signals there. The VDD and VSS ring was again shifted upwards by an offset of 20. I use these switches in the ICC2 PNR setup.tickle. I have used 0.1 as max density, and I have used a high connectivity, high congestion flavor. This is my floor plan, and the switchable domain is at the center and the pins are at the bottom side. The IR drop analysis shows 84 millivolts on VDD and 85 millivolts on VSS. So it's pretty manageable IR drop. So the placement after the place opt stage, the utilization increased to 0.31, and the GRC overflows are around 1200. With the full GRCs, it's huge, but I couldn't reduce it further. And a good thing is I could get clean DRCs after route opt. So the clock opt CTS, I have used the normal RM flow which generated the clock tree up to level 3, and this is how it looks. I just want to show the comparison between the timing violations that I had before and after using the multi-cycle path. So there were huge setup and hold violations, which got reduced to just 5 for the setup and no hold violations. After the route auto route opt stage, I got clean DRCs, and there are no timing violations as well. So the next task was to reduce the LVS errors that I got after the chip finish and ICV in design. The timing violations increased for the setup after using the prime time timing results, and there are still no hold violations. So I reduced these using the techniques shown for the lab. Around now from 110 I have reduced it to 41. Still I'm working on it to reduce it further. For fixing the LVS errors, I have used the methods discussed for the labs. I have added VRs on the VDD of the level shifters as they were open. Then I have added the VDD route on the M2 layer, which connected all the M1 layer VDD straps, and I have added the VDD and VSS port on the M4 layer and used these commands to remove the short nets and to add the missing VRs on the selected net. For the LVS max errors, which was set to 1000, I saw there are open VDD, VSS, and VDD core. Also, there are few short violations along with the floating route violations. So I could remove the VDD core, like I could fix the open net for the VDD core by routing manually at the center of the core, which was a bit difficult task since my switchable domain is at the center. Uh, while fixing the open VDD core, I have added a lot of short violations, but I could fix them like further till I complete the report. So for my further plan is to fix all these LVS errors and then work on the hierarchical design. Thank you.